So here we can do C, D, and E. Now, part C here, we want to prove that g of f of x does not exist. So I'm just going to start off doing my little sketch here. So if I think about this here, starting off with x, and we're doing it, what are we doing first? So we're doing g of f of x, so therefore we must do f of x first, and then perform the function g on that, so that will give you g of f of x, so therefore we know that f is the first function that we form, then followed by g. So we're going to have the domain of f, will give us the range of f. Second part of the function goes for the domain of g, and then we'll get out the range of g of f. This is the key to proving that it exists or it doesn't exist. In this case, it's not going to exist, which means the second part of the function, we're going to have values that are going to stop it working. So if we look at the domain of f, that's r. So that's going r here, and then we've got the range is -6 to infinity. The domain of g is -2 to infinity. So the second part of the composite function, you see, only works for values between -2 to infinity. So the problem is we're getting values out like -6, -5, and all these other values that are going to stop it working. So these are the values that are going to stop this working. So to show that it doesn't exist, then what we would write is, because the range of f is not a subset of the domain of g, therefore it does not exist. Okay, so for example here you see, is a subset of means that it lies within, so all these values -6 to infinity don't lie within -2 to infinity. You're getting values that are not going to work for that second part of the composite function, and that's what you have to say to prove it doesn't exist. Alright, so then let's look at D. So D is the largest domain, so what we want to do is we want to make it exist. So we want to stop these values here, the -6 to infinity, that are stopping the composite function working. And the way that we're going to change what we're getting out here, what we're getting out for the range, is by changing the domain. So we're going to restrict this domain of f, and therefore we'll get the function working. So again, the reason it's not working is because we're getting these values such as -6, -5, -4. I mean, you're not just talking about integers. So for it to exist, it will exist if the range of f is greater than or equal to -2. So we need to change these values here so that they all fit in here. So that's the biggest range that we can have here. So when we work out the range of f, we use the function f, which is this function here. Okay, so x squared. Now, what I'm going to do here is I'm going to use the factorized version, so it'll be easier to solve. So we can say that x plus 2 squared minus 6 must be greater than or equal to -2. And then we're solving this. Quadratic, so we want to take this over here, so that's going to be equated to 0. And then we want to solve this inequation, quadratic inequation. So we got -2 minus 4. It's a happy one, so it's going to be like this. And then we'll actually go through this. Okay, so all we want to do is work out what these intercepts are. Probably should have done that before I drew it. Let's see here, we've got x plus 2 squared minus 4 equals 0. So x plus 2 squared is going to equal 4. X plus 2 equals plus or minus 2. X equals -2 plus or minus 2. So x equals -4 or 0. Okay, I'm sure you can work that out in your head, but that's how you do it. So therefore, we're looking for where this is greater than or equal to 0. It's going to be this section here and this section here. So therefore, my x values are going to be -infinity to -4, and it's going to be including or 0 to infinity. And that's what your domain is going to be. So your domain is going to change to that. Okay, so by restricting the domain of the first part of the composite function to these values here, are going to stop you getting out these values that are stopping the second part of the function working. So that'll be what your domain of h of x is going to be. No, it's not h of x, just g of f of x. So what we want to do now is work out what the domain and the range is. So we've just done that. So this is what your domain is going to be. There's this E, okay, so E. So the domain of, did we call it anything? No, g of f of x. So it's just this. So negative infinity to that, or 0 to infinity. And then to get out the range, what we're going to do is we're going to use the graphs to get the range again. So we need to look at a little sketch here. So what's happening here is we're getting these values out here. So we're restricting this to -2 to infinity. So let's have a look at that. So if we just look at this new domain that we've got here, is going from negative infinity to -4 and 0 to infinity. If we look at f now, you see here this will be -4 here, it'll be symmetrical. So this will be like this. So by restricting this domain here, you see we're missing out all these values. So then it's just like this. So the range of that function is going to be -2 up to infinity. So therefore, we'll see in this sketch here, you see, that we're changing this to -2 to infinity. So that's going to be the domain. So then what we want to do to get the range is just look at this part here, g. So if we look at the graph of g for having the domain of -2 to infinity, which you already did, then the range is going to be 0 to infinity. So for this one, it's not too much work. So the range of g of f of x is just going to be the same as the range of the second part of the function, which was g, which was 0 to infinity.